Hello and welcome to this section of the Algebra Tutor. In this section we're going to talk about natural number exponents. It's kind of a broad sounding title, but basically what we're going to do in this section is learn how to work with exponents above and beyond what we've already talked about to help us simplify expressions. You know, most of algebra, to be honest with you, is learning how to simplify expressions. And a lot of students, when they start seeing exponents running around, you know, x to the 5, x to the minus 3, and other exponents everywhere, they just kind of freak out a little bit for no reason because it seems foreign to you. Until you get to algebra, you haven't dealt with exponents a lot. And exponents are everywhere in algebra. So, you know, a lot of students get uneasy. They don't know how to simplify. They don't know how to combine terms with exponents and things like that. We've talked a little bit about this in previous sections, but here we're going to just punch it in the face and really get on top of exponents and go over every little detail of how you simplify these things. I'm not going to lie, it's a little bit of a long section. So make sure if you have to take a break or whatever, go ahead and pause the video and do that. Make sure you can do everything and understand everything in this section. I promise you it will make your life easier as you go on. And the good news is, I'll promise you when I tell you this, it's not hard. Let me just teach you the steps and we'll go from there. So let's do a little bit of a review. Let's walk, let's crawl before we can walk. All right. And so we'll do a little bit of a review. When we have something like 5 raised to the power of 3, then we already talked about the fact that what this is basically saying is it's 5 times 5 times 5. We multiply the 5 by itself, the number of times that the exponent represents. So it's a shorthand way. Instead of writing all this multiplication out, it's a shorthand way of writing multiplication. So when you see exponents, try not to think, oh no, that's a crazy looking algebra thing. Think, that's just multiplication. That's all that exponent is. So hopefully break down, you know, some fears if you have any of those. If you have anything like, you know, negative 4x raised to the power of 5, if you were going to expand this out, it would make it negative 4 from the front times x times x times x times x times x. I've multiplied x times itself 5 times because of this. And then the negative 4 is also being multiplied by the whole thing, so it's just kind of sitting out in front. So wouldn't you agree that taking this, writing this out is kind of cumbersome, so we have this nice shorthand way of writing the same thing. If you had something like negative 2y raised to the 4th power, that's negative 2y times negative 2y times negative 2y times negative 2y. And anytime you see parentheses just sitting next to each other, it means multiplication. We're multiplying everything inside the parentheses, which is negative 2y, times itself 4 times. So everything in here is raised to the power of the 4. All right, now let me get to the first thing that we're really going to learn in this section. What if you were simplifying something like x to the 4th multiplied by x to the 3rd? All right, so you want to simplify that. Now we already learned how to add and subtract exponents, right? And or I should say terms that have exponents. And we said the only way you can add or subtract them is if everything matches, the variable matches, the exponent matches, then you can add the numbers in front. But when you're multiplying exponents, it's almost easier because really all you do is you keep the bottom thing, the x, and you just add the exponents together. So what you'll get is x to the 7th. That is the simplification or combining these things together into one thing. And when you think about it, I'll show you how this makes total sense. Okay? Because what you really have here, this x to the power of 4, this is basically x times x times x times x. That's what it is, 4 times, 1, 2, 3, 4. And it's multiplied by x to the 3rd power, which is x times x times x. So I put the parentheses here just to kind of show you that this goes with this and this goes with this. But really you don't need parentheses here. Everything's multiplied together, so I could kind of take them off if I wanted to. Everything's multiplied together, so the parentheses don't really matter much. So what do I have here? I have x times x times x times x times x times x times x. So I have x multiplied by itself 1, 2, 3, 4, 5, 6, 7 times. And that is why we add the exponents together. In order to add exponents, the base, which is the x in this case, they have to be the same. So x matches with x, so we keep the base the same, right, which is everything we're multiplying together, and we add the exponents together. Because ultimately, this is what's happening. All right? What if you had x to the 5 times x to the 5? First thing you check is you see, are the bases the same? I have x and I have x, so yes, I can multiply these together. I'm going to add the exponents and I'm going to get a number 10, right? X to the power of 10. I just add them. And again, if you wanted to convince yourself of that, this is x times x times x times x times x, right? And this is all multiplied by, I'll put a big dot here to represent that it's multiplied by the next thing, x times x times x times x times x. Everything's multiplied together, so really, I have x to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 power. So that's why you add exponents together. There's always a reason behind it. All right, so let me go and erase the board and we'll continue building on what we've learned here to go inch our way to the more complicated problems. All right, what if you had y to the power of 3 times y squared y to the 4th power? And you wanted to simplify that. You're typically taught to do everything inside of the parentheses first. So let's go ahead and do it that way. The y to the 3rd, we could just leave it out for now. And inside, we have the same base, which is y. So we can multiply these guys together and add the exponents. 2 plus 4 is 6. So we'll have y to the 6th. Now notice that we're just multiplying these together. And again, I have y here and a y here. So I can keep the base the same and I can add these exponents. 6 plus 3 is 9. So that would be y to the 9th power. So basically, anytime you're multiplying things that have exponents, when you're multiplying variables that have exponents, you can combine the exponents together by adding the exponents only if the bases, in this case y, match perfectly. All right? Let me change colors here just to break it up a little bit. What if I have 4x squared times 3x to the 5th? Something like this. What if I have that? All right. Well, what you have going on here is multiplication. The 4 times 3 is still going to stand, so you're going to have 12. But just to keep it clear, let me write everything else out. I'm going to have 12 times x squared, and I'm still going to have the x to the 5th. Basically, I'm multiplying the numbers, but everything else, let me just kind of keep along for the ride so you can see what I'm doing. Now you can see I have x and I have x, which match. I can add these exponents. So 12x, 2 plus 5 is 7. So 12x to the 7th power. So we're inching our way forward, doing problems that are a little more complicated each time. What about negative y squared times 4y to the 3rd power? How would I simplify that? Well, I have a 4 times this negative 1. So I'm going to have negative 4y squared times y to the 3rd. I'm just hanging on to these because I just want to do everything in separate steps. The negative 4, the y's match, so 2 plus 3 is 5. I can add them together. If this were not y cubed, if this were like x cubed, then y squared times x cubed, I wouldn't be able to add them. I wouldn't be able to combine them. I'm only able to do it because the base, which is y, is the same in these cases, in these problems. And we'll get to some more problems in a minute where we'll not be able to combine them together. But for now, let's say we have something like 6x cubed times negative x squared times negative x to the 4th power. So we're getting a little more complicated each time, but not too bad because when you really look at what we're doing, we have a 6 times a negative 1, and this is also a negative 1. Basically, all of the numbers, if everything's multiplied, the numbers can be multiplied. So negative times negative gives you positive. We're still going to have a 6. Let's just keep our variables along for the ride now. Basically, the negatives went away because of the multiplication. Now when we look here, we see, well, we have x cubed, x squared, x to the 4th. X is the same in each case, so we can keep that along. And we can just simply add the exponents together. So 3 plus 2 is 5, 5 plus 4 is 9. So we have 6 times x raised to the power of 9. All right, so not too bad. And keep in mind, we're only able to combine these guys because the base here, which is x, is actually the same. So let me give you an example to illustrate that. What if you have 12x squared times y to the 9th? And I said, simplify that. Well, you should look at that and say, well, there's nothing to multiply. 12 is already there. I have x squared and y to the 9th. These are different animals. This is x times x, and this is y times y times y, all the way doing it 9 times. There's no way to combine x squared and y to the 9th. So you just say can't simplify. Or you could just write already simplified or already simple form. You can't do anything more with it. this is it. You can't simplify this anymore because you can't combine things that are different. All right, so let me go and erase the board, and I'll introduce another rule to you that's going to be very useful as well. All right, now up to this point, I've taught you the basic idea of exponents. We've talked about that, and we talked about what to do when you have something multiplied by something else, and each of them have an exponent, and the bases match. You can add those exponents together. Now we're going to learn about how to handle a situation when you have something like this. We have something squared, and it's raised to a power. Or in a more general sense, you have an exponent raised to another exponent. Raised to another exponent. The way you do that is you leave the base the same and then you multiply the exponents. 4 times 2 is 8. So it's 3 raised to the 8th power. And I want to briefly show you how this is possible so you know that I'm not just making up things. If you have 3 squared raised to the 4th power, what does that mean? It means you have 3 squared times 3 squared times 3 squared times 3 squared. Everything in the middle is multiplied by itself 4 times. That's the definition of what an exponent is. But notice that everything in here is squared. So really what I have is 3 times 3, 3 times 3, 3 times 3, and 3 times 3. 1, 2, 3, 4, 5, 6, 7, 8. This is 3 to the power of 8, which is exactly what I told you. So I'm showing you by an example. Basically, if you have a power raised to another power, you just multiply the powers together. So they're all simple rules. It's just that, you know, like anything else, you have to have practice with the rules, or you're just not going to do. You're not going to do well with it. So let's practice this. What if we have y to the power of 5 raised to the 3rd power? We have something to a power raised to another power. So we just say it's y, 3 times 5 is 15. That's as simple as that. You multiply the guys. So the bottom line is, sometimes you add exponents if the two terms are multiplied together, but if you have a power raised to another power, you have to multiply the exponents. All right, what if we have a to the 3rd power raised to the 7th power? 3 times 7 is 21. All right? And what if you have something like x squared times x to the 3rd inside the parentheses, and you raise the whole thing to the 5th power? How would you handle this? Well, I'm teaching you another rule kind of on the fly as we go. When you have lots of different things multiplied together inside of a parenthesis and you're raising them to a power, you can sort of distribute this power in to those exponents, kind of like we do when we distribute, you know, anything else when we multiply things. So what you'll have is x, 2 times 5 is 10, and it's multiplied by x, 3 times 5 is 15, like this. So you get x to the 10th from this, x to the 15th from this, and notice when we look at this, we can actually combine these guys because we have common x. We add the exponents in this case, so we'll get x to the 25th. So this is the answer. Now notice we did it this way. I showed you how to distribute the exponent in, getting these two terms, and then you can add the exponents, getting the answer. But there's another way to do this problem. There's always different ways to do problems. You know, what I'm going to do now is simplify what's inside the parentheses first. Notice I have x squared and x cubed. I can basically convert that to x to the 5th power because I can add these exponents in the middle. Now I have x to the 5th raised to the 5th power. So 5 times 5 is 25. So no matter how you do the problem, you're going to get the same answer. And there's always, I can't say it enough, there's always going to be more than one way to do a problem. And this is a perfect example. All of these simplifications of exponents are going to happen like that. You could combine them first and then raise them to a power, or I can do the powers first and then combine them at the end. You should always get the same answer each time. In fact, it's a good way to check your work. All right, let's say we have 3 times z squared times z cubed, all raised to the 5th power. All right, all raised to the 5th power. And we want to simplify this. Now, there's a couple ways we could do it. I could distribute this 5 in everywhere. It would have to go to the 3, and then it would have to go to the z squared, and the z cubed. But, you know, just to show you different ways to do the problem, I'm going to instead do it like this. Let's work on the inside first. I have a z squared, and a z cubed. I have the same base, so I can add these together, and I'm going to get z to the 6th by just adding the exponents. Now, everything is still raised to the 5th power. Now I can't really simplify anymore, so what I'm going to do, I can't simplify inside here anymore, so I'm going to distribute this 5 in to both places. Now notice the 5, the exponent 5, is going to go and apply itself to the 3 and also to the z to the 6. So anything in there gets affected. So what you're going to have is 3 raised to the power of 5 times z raised to the power of 6 times 5 is 30. So you're going to have 3 to the 5, z to the 30th. So here it just, notice this is like 3 to the 1. So 1 times 5 is 5, 6 times 5 is 30. And you get the same answer either way. We combined first and then applied the exponent. If I apply the exponent to everything individually and then simplify, I'm going to get exactly the same answer in that case. And that's always the way it should be. Okay? What if we had something like r to the 3rd power times r squared raised to the 4th power multiplied by r cubed r to the 5th raised to the 2nd power? So again, there's many ways that we could do this, but again, to show you, I could combine these guys, and then I could combine these guys and then raise the powers, but just to show you different ways to do it and show you the power of the algebra, I'm going to apply the 4 to both of these guys first. So what I'll have here is r cubed raised to the 4th power, r squared raised to the 4th power, and here, when I take and apply here, I'm going to have r cubed raised to the 2nd power, r to the 5th power raised to the 2nd power. So basically you apply the exponent to everything. Here we have r to the 12th because 3 times 4 is 12. Here we have r to the 8th because 2 times 4 is 8. Here we have r to the 6th, and here we have r to the 10th. Now look, I have r's everywhere with different exponents. I can add these guys together. So what I'm going to get, 12 plus 8 is 20. And then I have 30 from this, and then 36. So r to the 36. So all of this mess simplifies down to r to the 36th power. And it's going to work the same way. See, here we distributed first. If I combine this guy and get something, and then I combine this and combine something, and then apply the powers, I'm going to get exactly the same answer in the end. Okay? So let's go on and do this guy. X times y raised to the 3rd power. How would you simplify this? Well, about the only thing you can do is apply this exponent in like this. So what you'll get is x to the 3rd power, y to the 3rd power. 3 times 1 is 3. 3 times 1 is 3. And you can't do anything else here. You can't combine these because I have an x here and a y here. I can't add these exponents because I've got different guys going on there. So I'm basically done. All right. What if I have r to the 3rd times s squared all squared? Well, I can't combine these guys in the middle because they're different base variables, so I'm going to apply the 2. r, 2 times 3 is 6, s, 2 times 2 is 4, and this is the answer. I can't combine these anymore because I have r's and I have s's, so I can't do anything else there. So we're applying the rules. It looks like a lot of work and a lot of things to remember, but really there's only a few different rules and a lot of practice to help you get good at it. All right, let's say we have negative 2 times r squared times s to the 3rd times t all raised to the power of t, of 3, I should say. Okay, so we look inside, we can't really combine anything. We have r's and s's and t's, so we can't combine any exponents in there. The only thing we can do is distribute this exponent in. It would apply itself to the 2, it would apply itself to the r squared, it would apply itself to this, and it would apply itself to that guy. So it's going to apply itself to everything. So what you have here is negative 2 raised to the power of 3. Then you're going to have, just to make it totally clear, r squared raised to the power of 3, then s to the 3rd raised to the power of 3, then t raised to the power of 3. Just to be absolutely clear so that you know what I'm doing, I'm applying the cube to everything. Now when you look at this, negative 2 raised to the power of 3 is negative 2 times negative 2 times negative 2. So if you think about that, that's going to give you negative 8. Here, you have a power raised to a power. So you multiply. 2 times 3 is 6. Here, same thing, you multiply. 3 times 3 is 9. Here, there's nothing much to do except apply it. Or you could say 3 times 1 is 3, I guess, if you want to do it that way, just to remember it. So you have negative 8, r to the 6th, s to the 9th, t to the power of 3. All right, so we've done a lot with multiplying exponents together and how to handle that. We've done a lot with raising an exponent to another exponent. Now we're going to go figure out what to do when you have some stuff on the top of a fraction with exponents, and then you have stuff on the bottom of the fraction also with exponents. When you get the hang of it, it's not going to be very hard at all. In fact, it really isn't hard. It's actually kind of fun, in my opinion. All right, so what if you were doing something like a over b, and you raise the whole thing to the third power? How would you do that? Well, it's something you need to learn, but when you have a fraction and you're raising the whole thing to a power, you can apply the power to the top and the bottom of the fraction separately, like this. So this is the only thing you can do. This is the answer. So the cube gets applied to the top, and the cube gets applied to the bottom of the fraction. It's kind of the same thing as the distributive thing when the cube goes and affects everything inside. Well, the cube goes and affects everything inside of here as well, top and bottom. So it's kind of an expansion of what you already know, really. So let me switch colors, and then we'll say, what if you had something like, we'll kick it up a little bit, x squared over y cubed, all raised to the fifth power. So you can't do much inside because you have x's and y's, but you do have this fifth power here that you can operate. So on the top, it'll be x squared raised to the fifth power. On the bottom, it'll be y cubed raised to the fifth power. The exponent applies to the top and the bottom of the fraction. Now we revert back to what we know. We have a power raised to a power. So on the top, we multiply 2 times 5 is 10. On the bottom, we multiply 3 times 5 is 15. And this is the answer, x to the 10th over y to the 15th. We just have to handle it one step at a time. Apply the exponent to the top and separately to the bottom. Then use what you already know to simplify these exponents. So it's a good example in algebra of how we learn these little rules and we kind of incrementally build. See, if you didn't remember how to do this, then you couldn't finish this problem. And so a lot of students, if they don't understand something, they'll just kind of punch through it and get on to the next section, and then they're even more lost. So it's going to actually save you time if you practice this and get really good at it and then move on, rather than trying to punch through it and then trying to, do poorly later on. It's just not going to work out in algebra. All right, so we have this guy, and we'll switch colors. Now, what if we had something like, negative 2a over b, all raised to the power of 5. It's exactly the same principle. We've got a fractional raised to an exponent, so it applies to the top and to the bottom. So to make it clear, you have negative 2a on the top, all of it's raised to the fifth. On the bottom, you're also raising it to the fifth. Now, you should recognize the top. What do you do when you have lots of things inside of parentheses raised to a power? You distribute the power in. So really what you have is like negative 2 raised to the power of 5, and then you apply it to the a. You have a to the 5, and then you have b to the 5, and you can't do anything with the a's and b's because they're different. So basically this is the answer. Now you could go in your calculator and do negative 2 times negative 2 times negative 2 times negative 2 times negative 2, and you could put a number there, that's fine, but I'm just going to leave it like here just to illustrate what's happened. You've applied the exponent 5 to the top and to the bottom, and then here for the top you distribute it in because we've been doing that before. So you're using an earlier skill to apply to these later problems. Okay, so now we're going to switch gears a little bit. It's not really totally switching gears, but a slightly different skill. What if you have x to the fifth over x to the third? Now this is not raised to the power of anything. We're not distributing a power in. We just want to simplify what we have here. All right, now if you remember, what I told you is if you had two things multiplied together that had the same base and you had exponents involved, you just add the exponents. So what do you think you're going to do if you're dividing two things with the same base and they have exponents? Well, it turns out you subtract them. You start at the top and you subtract the bottom. So you have x, 5 minus 3, x squared. So you subtract the exponents. When you have the same base on the top and the bottom, different exponents, you can subtract them. This is very similar to when you're multiplying things with exponents of the same base, you can add the exponents. Now let me show you really quickly why this actually works, or another way to show you how it works. On the top here, you have x to the fifth. So that's x times x times x times x times x. That's what's on the top. On the bottom, you have x times x times x. Now, what do you think is going to happen? We have commonality on the top and the bottom for this x, and also for this x, and also for this x. Let me ask you a question. What is 2 divided by 2? Well, that's just 1. What is 3 divided by 3? Well, that's 1. Well, here I have x divided by x here. So it's just basically going to give me 1. So this x can cancel with one of the bottom x's, this x can cancel with one of the bottom x's, and this x can cancel with one of the bottom x's. So I can kind of strike them out. Only thing I'm left with is x times x, which is x squared, which is exactly what I wrote here. So the shorthand way of doing it, when you're working your problems, is really all you're going to do. Well, one way to do it is you're just going to subtract the exponents. You're going to subtract them, top minus bottom, that's it. Boom. Another way to think about it, a way that you'll use more and more as time goes on, is you'll start to view the top as having lots of x's, and you'll start to view the bottom as having fewer x's, and I can cancel 3 of the x's in the bottom with 3 of the x's in the top, leaving me with only 2 x's. Now don't forget it's x squared because it's x times x. So both of these are useful. If it's better for you to remember to subtract them, fine, do that. If it's easier for you to think of canceling them, then do it that way. And I'm going to kind of show you both as we go through here as well, just to give you extra practice. Okay, what if you had something like x to the third over x to the fifth? Basically, this is the exact reverse of this. Same thing applies. It doesn't matter if the top is smaller. It's x, 3 minus 5, x to the negative 2. And yes, you can have negative exponents. And we're actually going to talk a lot more in the next section about negative exponents. So don't worry too much about it now if the idea of a negative exponent bothers you too much. But I will give you one clue. When you have a negative exponent, algebraically, all you do is you say it's 1 over the same positive exponent. So you can take this negative exponent, move it downstairs 1 over, and make it positive. These two things are the same thing. So if you ever get a negative exponent, all it means is you really have something in the bottom of the fraction. So if it helps you to remember by subtraction, do it that way. If it helps you to remember the other way, do it the other way, which would be the following. X times x times x on the top, x times x times x times x times x on the bottom. And so when you look at it this way, you say, well, I've got 3 x's on top. I can cancel all 3 of the x's I have on top with the ones that are on the bottom. And this is just a 1 up here. When you cancel everything, you're left with 1, basically. So what you have is 1 over x squared, which I've told you, anytime you have 1 over a power, you can write it as a negative exponent, which we'll talk a lot more about in the next section. So whether or not you think of it as subtraction to get the answer, or if you think about it as cancellation, either way is fine. We're going to do both as we go further on in the lesson. All right, what if we had y to the third times y to the fourth over y times y squared? And we want to simplify that. Well, the simplest thing to do would be to combine the top and the bottom and then deal with the fraction later. So let's do that. Here we have y cubed times y to the fourth. We have the same base, and we can add the exponent. So that would be y to the seventh on top. Here we can do the same thing. This 1 plus 2 can give us y cubed on the bottom. And now we're left with this. We have an exponent on the top, exponent on the bottom, same bases. So we can just do y, 7 minus 3 is 4, and that is going to be our answer, y to the fourth power. All right, so we're kind of just working extra problems here to build these skills up. What if you had 12 times a squared times a to the third times a to the fourth over 4 times a to the fourth raised to the power of 2. How would you simplify this? You just take it one step at a time like you always do. On the top, we have a 12, and we have a cubed, a squared, a cubed, a to the fourth. We have a everywhere, so we can just add these exponents. 2 plus 3 is 5, plus 4 is 9 on the top, so a to the ninth on the top. On the bottom, we have a 4, but now we have a power raised to another power. We just learned that when you have a power raised to a power, you multiply them. 4 times 2 is 8. Now this looks a whole lot simpler, right? Now what we can do for a final answer, we have a 12 divided by 4. We know that's going to be 3, right? And then we have an a to the 8th and an a to the 9th. Right? So we can subtract them. That's true. That's 9 minus 8 is going to give us 1, a to the first power. So you can put a to the first power, so you don't even really need to do anything. So that's the answer, 3a. But in kind of an alternative way to think about it, which you're going to use more and more, is you can think about it like this. Here there's 9 a's up here multiplied together. Here there's 8 a's multiplied together. So you have all these a's and all these a's. All 8 of these a's are going to basically cancel with 8 of the a's from the top. And I'm going to strike through the exponent and basically remind myself I only have one exponent left over. Because I'm basically striking through and I'm saying, okay, 8 of these guys are canceling up here. So I'm going to since I only have 9 of them, I'm only going to have 1 left. So I'm going to be left with 8 to the first power. And as time goes on, I'm going to do this more and more to kind of show you the different ways. The easiest way to do 9 minus 8 gives me 1. That's how you do it. Fine. But it's also very nice to look and say, okay, I have 8 a's here, canceling, strike through the 9, put a 1, reminding me that I only have 1 a left on the top. So you need to start looking at these fractions with variables and exponents as cancellations. If you have x's on top and x's on bottom, start thinking about them in terms of, well, these x's are going to go away because they're both on the top and the bottom. And what I'm going to be left with is what I'm going to write down. So very important. I'm kind of inching you through it. Okay, so we have another opportunity to do that here. What about a times b squared raised to the third power times, or divided by ab to the second power? All right, we can't do anything inside because we have a times b. They don't match at all, but we can distribute this exponent in. So what we're going to have is a cubed b to the 6th power, because 3 times 2 is 6, 3 times 1 gives us 3. And here I'm going to have a squared b squared. All right? Now, there's really 2 ways to do this, like I'm saying. What you have here is, you have the same, it doesn't matter that these are multiplied here. It matters more that you have a's on the top and a's on the bottom. So here you could say 3 minus 2 gives you 1, so it's a to the first power. Here you have 6 minus 2 is 4, so you could do b to the 4th power. So the answer is a times b to the 4th power. But it's also important as a different way to teach your mind how to do this, is to view this as, look, I've got 3 a's up here all multiplied together, and I've only got 2 multiplied together on the bottom. So both of the a's down here can cancel with 2 of the ones up there, leaving me with a to the 1st power. I'm just going to kind of rewrite this exponent with a 1 to remind myself of that. I have the same thing here. I have 2 b's down here multiplied together, which can cancel with 2 of them up here, and that's going to leave me with 4. Because once 2 of them cancel out with the 6, I'm going to have 4 left. So you can kind of do the cancellations, and you can immediately say a to the 1st power, b to the 4th power. Either way is fine. If you prefer to think of it as subtraction, do it that way. If you prefer to think of it as cancellation, do it that way. If I had to ask you which one to sort of in your mind think about more, think about the cancellation more. Because when you get to large terms, it's going to be much easier for you to strike through these exponents, canceling everything when you can, than it will be to do subtraction. But really at this point in the game, either way is fine. As long as you're getting the right answer, you're on the right track. All right, we're getting close to the end of the section. We've pretty much hit all of the problem types. Now we're just kind of getting practice. All right, so we have something like this on top, and on the bottom we have 6rs cubed. So what would you do first to simplify this? Well, you have numbers. 20 divided by 6, what is that going to do? Well, you can't really divide them out, right? You can't divide those guys, but you can simplify it. You can divide the top and the bottom both by 2, right? So if you divide the top by 2, you're going to get 10. If you divide the bottom by 2, you're going to get 3. So we basically are simplifying that fraction. And then in here, we're going to distribute the 4 as the exponent in. So what you're going to have is r, 4 times 4 is 16, and then you're going to have s, 4 times 3 is 12. So that's what's on the top. On the bottom, you're going to have 3 applied here, so you're going to have r cubed, and 3 applied here. 3 times 3 is 9. So there you go. So now at this point, do some cancellations, really. So on the top, we have 16 r's multiplied together, and on the bottom, we have 3 r's multiplied together. So all 3 of these r's can cancel with 3 of the r's from the top, and I'm going to be left with 13 r's up there. So I'm going to replace that exponent with a 13. Here, I have 9 s's on the bottom and 12 s's on the top, all multiplied together. So all 9 of these s's can cancel with 9 of them here, leaving me with only 3 s's in the top. So I can replace that exponent with a 3. Now you just read the answer off. 10 over 3, and then you have r to the 13th power, s to the 3 power, to the third power, and that's it. So 10 thirds r to the 13, s to the third. So, you know, really, honestly, not very hard. It's just you got to make sure that you're really looking on the top and the bottom and making those cancellations. What if we have something like 17/34, and on the top we're going to have x to the 4th, y to the 3rd, all raised to the 8th power, and on the bottom we're going to have x to the 5th, y squared, all raised to the 4th power. All right, so we want to simplify this. How do we do it? So we have a fraction here. It may not jump out at you right away, but if you divide top and bottom of this fraction by 17, it'll actually reduce. 17 by 17 is 1. 34 divided by 17 is 2. So we basically get 1/2 there. And then here we're going to use this exponent and kind of distribute it through. We can't simplify anything inside because we have x's and y's inside. So here you're going to have x raised to the 8 times 4 is 32. And here you're going to have y, 8 times 3 is 24. And on the bottom, you're going to have x, 5 times 4 is 20. And you're going to have y, 2 times 4 is 8. So we've got everything in the form that we want, and now we start looking. You can do subtraction, 32 minus 20, 24 minus 8, that's fine. But I really would like you to get in the habit of thinking about it. I have 32 x's up here multiplied together, and I have 20 x's multiplied on the bottom. So I know that all 20 of these x's can actually cancel with some of these, and I'm going to have 12 left. So basically you're kind of just doing the subtraction here is really all you're doing. Here I have 24 y's, and I have 8 y's on the bottom, so I know all 8 of them are going to cancel out with this guy, and I'm going to have 16 left over. All right, after you do the cancellation. So the final answer is going to be 1/2 times x to the 12th, y to the 16th. When I strike through the whole thing down here, they're gone. I just have 1 down there. On the top, I just have my exponents that I've replaced. So it's 1/2 x to the 12th times y to the 16th. All right, so here is kind of one of the big kahunas. Here you have y to the 3rd times y over 2 times y squared. All of this is raised to the 3rd power. So how would we simplify this? And this will be our last problem before we do a review. Well, there's lots of ways to do it. You can combine on the inside first. You certainly could combine these and make y to the 4th power. You could combine these. That's fine. That's totally okay. But I'm going to show you, the more difficult way, just to show you that it's possible to do it either way. So let's apply this exponent to the top and separately to the bottom. So what I'm going to have is I'm going to have on the top y cubed times y raised to the 3rd power. On the bottom, I'm going to have 2 times y squared to the 3rd power. Okay? And so again, I could combine these here and then combine these here, but I also know that I can distribute the exponent into whatever's inside the parentheses. So let me just show you that way. So you'll have y, 3 times 3 gives me 9, y to the 3rd power, just multiplying 1 times 3. On the bottom, you're going to have 2 raised to the 3rd power because that applies to everything down there. And then I'm going to have y to the 3rd power, 3 times 1, and then I'm going to have y, 2 times 3 is 6 down there. And now that I'm at the final end here, I can simplify this. On the top, I have the same base, which is a y, but I have those guys, which are 9 and 3, so I can add those together. On the top, I'm going to have 12, y to the 12th power. On the bottom, 2 to the 3rd power is 2 times 2 times 2, which comes out to 8. And here I have y cubed times y to the 6th. I can add these exponents and give me y to the 9th. So I'm basically almost done, but I noticed that on the top and the bottom, I have some y's. And I notice that I have 9 y's on the bottom and 12 on the top, so I know that all 9 of them will disappear, and I'll be left with 3 y's on the top. So my final answer will be y to the 3rd power over 8. Y to the 3rd power over 8, because when you strike through it, this basically means it's 1 down there. And that's the final answer. Now, there's always different ways to solve algebra problems, always. Let me show you a quick different way. If I wanted to do it a different way, I would take this guy, start from the beginning, like this, And I could combine from the beginning. I know I can combine the top here and make this y to the fourth. And underneath it, it's going to be 2 times y to the third because I'm going to combine these guys. Everything's still wrapped like this. So on the top, when I apply this guy, it's going to be y to the 12th. 3 times 4 is 12. Here, it's going to be 2 raised to the third power. And y, 3 times 3 is 9. So I have y to the 12th. 2 cubed is 8, y to the 9th, like this. And we just figured this out, that when we can strike through this, it leaves me 3, y cubed over 8. I get exactly the same answer as I do here. So I know that I can simplify first and then apply the exponents. I also know that I can distribute the exponents in and simplify later. As long as you're following the rules and not making up your own rules, you're always going to get the right answer. So let me go ahead and erase this board and write down a little summary for you to help remember all of the things we've learned in this lesson. All right, so as a summary, we've done a lot, so let's summarize. Basically, if you have x to some power, I'm going to call it m, times x to a different power, n, you can add the exponents, x to the m plus n. And this is basically just like, as a concrete example, x squared times x. You can just add the exponents and make it x cubed. So that's the first rule that we used. Secondly, you can have x raised to a power and then raise it to a different power, and then you just take the bottom and you multiply the exponents, m times n. Whatever m and n are, you multiply them together. This is just like x cubed raised to the power of 2, x to the 6th power. 2 times 3 gives you 6. Okay? The third thing we learned is that x times y can be raised to a power, and when you have something inside of parentheses raised to a power, you can distribute it in. So x to the n times y to the n. And this is exactly the same, given a real problem, as something like x times y squared. It's x squared y squared. You just distribute the exponent in. And finally, the last thing we learned is if you have x over y inside here, raised to the power of n, then basically you apply the exponent to the top and the bottom. So x to the n, y to the n, like that. So the way this works, given a real example problem here, would be something like, x, let's just do x over y, and you're raising it to the 4th power. That's going to be x to the 4th over y to the 4th. You just apply it to the top and also to the bottom. These are the 4 rules. Now, most books show you this. Most students look at that and get completely freaked out by it, don't understand what it means. If I just wrote this on the board in the beginning and said memorize these rules, everybody would have a hard time. Most people would have a hard time. But I hope that by starting small without this, but with real problems and showing you, hey, in this case you can add them, in this case you can subtract them, in this case you have to multiply them, and so on, then I think you can see by examples how to do this stuff. And I cannot stress how important it is because, simplifying these expressions with exponents on the top and the bottom really is kind of like the bedrock material. A lot of students have problems when you get to this part, but hopefully you've seen that it's really not a big deal. If any of this seems unclear, you must master it before going on. So watch this lesson as many times as it takes. Get a separate sheet of paper out. When you watch it again, work all of these problems with me. Pause the video and work them and check your work. When you're done with it, grab my companion worksheets and work a ton of other problems. Grab your textbook, work a ton of other problems. When you're confident that you totally know how to do all of these types of problems, then move on to the next section, and you'll be building your skills one skill at a time, and not only can do the problems, but be confident that you're doing them all correctly.